want you all to know why that's an ellipse, and I haven't even got it standard form yet. So, they're both squared. It's not a parabola, because parabola only has one of them squared. They're both positive. It's not a hyperbola. Hyperbolas have one of them negative. So it's down to circle or ellipse. I don't know which. The front numbers are not balanced. If it was 9 and 9, the sucker's a circle. If it was 4 and 4, it's a circle. They're not balanced. That's an ellipse. How do you get it to standard form? Right side would want to be 1. Well, keeping my scales balanced, I need to do that to everything if I want to divide by 36. So after one round, this would reduce to x squared over 9. This would reduce to y squared over 4 equals 1. And on these problems, they've been asking you to box that, standard form. Some of you, put the book away please, Aaliyah, have got the backwards going on your right, left, up, down. X is under the 9. So the 9 is tied to the x-axis. What's the square root of 9?
3.
3. We don't want to go right 9. We're going to square root the 9. There's 2 points of our ellipse. The 4 is associated with the y. This is the y. What's the square root of 4?
2.
2. And now be the best artist you can be, because we're done. There's where you've been. That was part 1 of ellipse. You see the parentheses 2, that means this is like chapter 2 of ellipse. Okay? Focus was a word we used for parabolas recently, right? Directrix, focus. Ellipses, with an ES, they have foci as well. So what gets this part 2 called part 2? Now they're going to give us focus or foci information instead of just equation information, and we're still supposed to be able to find a way to graph it. Okay? So they're not giving us all this every time. Let's get to 527, example 1. Write the standard form. So they want an answer like this. But all they're going to tell me of the ellipse is the vertices, positive and negative 5, 0, and the foci. All right. So let's get some rules set for foci. Let's get what we know so far. We know horizontally 4, 5, 0, 0. They gave me these 2 corners, which is half of what I need to graph it. And it's also half of what I need for my final answer. I know this much about standard equations for ellipse. What do I also know out of the 2 question marks? They've given me half of it. Which question mark do I know and what value should go there? The first one should be a 25. Right 5, left 5 would have been caused by this. Agree? So how the heck are we supposed to use foci information? What was it? Positive or negative 4, 0? To create this last question mark. Well, let's put these foci down. There's a focus. There's another focus. I can just get this. Okay. All right. Now, the focus lies on the major axis. That's important. First rule, the foci will always lay on the longest axis of the ellipse. So that means this thing is horizontal. Yeah? It's going to be squattier vertically than it was here. That's going to be less than 25. Focus lies on the major axis. And the little right triangle we're going to build takes the 4 that we already know. We already know that's 4. Agree? 4 units long. It takes the 5 that was half of the major, and it just basically transplants that. It says Move that 5 into a right angle look. Oops, I'm going to do even better. Because some of you guys are saying, I already know what this other one's going to be. Move that 5, half of the major, into a hypotenuse. And use Pythagorean theorem. What's this? I actually drew it to scale. 4 units, 5 units means this is 3 units. Well, that's all I needed. Oops. Right? That's all I needed was that how far up and how far down. I'm done. What needs to go in this other question mark then? Not a 3, but a 9. Again, focus is one of your sides of the triangle. You can go here, you can go here, doesn't matter, right? Take the 5, which is half of your major axis, turn that into a hypotenuse off of your focus, and you're going to use Pythagorean to get that third piece. That third piece, when you square it, gets you the standard form they want. So what hints do you get? Once they tell you the foci, you know which way it's stretched, because they lay on the major. After that, it's a Pythagorean problem. Flip it. Example 2, write the standard form of this one. We're going to have to change much? Not much. But is every triangle going to be a 3, 4, 5, like the prettiest triangle there ever was for right triangles? No. So, the thing about with this video, I don't have to worry about erasing crap. You can go back and look at it, right? I need a graph. If I'm going to do example 2, I need a graph. Even if you're here, you can go back and look at it. Example 2. Vertices are at 0, 6 and negative 6. What do I already know about my equation? Be careful. They've changed it up a little. What do I know? The y is going to have what under it? 36. Good. Now I got to use the focus information to get that other piece. They said the foci are at 0, 5 and 0, negative. That makes sense because they always lie on the major, they said. Right? Focus number 1. Focus number 2. Now either go here and build your triangle or go here, it doesn't matter, right? One of your legs is going to be a 5-unit leg. You're going to take the 6 and swing it out into a right triangle. I don't know how far to swing it out like I did on the last problem. I'm just sketching. I don't know where it's going to go. But I know this is 6. To find the actual value of this, looks like it's an a value, Pythagorean. A squared plus b squared equals c squared. All right. A squared plus b squared needs to equal 6 squared in this case. A squared and 25 needs to equal 36. Get me A. Jaden, how are you going to move 25? Minus it. How are you going to get rid of the square? Square root it. Well, here's the thing. 11 is what actually would need to go here. Right? Because this is radical 11, and what do you get when you square root and then square? 11. Find the standard form. It's not always pretty, 3, 4, 5. This one wasn't. This ended up being, what's the square root of 11? 3 point something, right? But I don't need the 3 point something. I just need the radical 11, because I'm going to square it anyway. Cool. Example 3. They didn't do this on, oop, yes.
Doesn't the 6, the hypotenuse have to touch the focus?
It did. Oh, I drew the picture wrong. Thank you. It should have touched the focus. Good. You're right. Work's not wrong, but my picture was wrong. Example 3. The second word, was huge. It's a horizontal ellipse. Where's the focus? Where are the foci going to lay? On the x. That horizontal word's important. The major axis is 10. Alright, let's get this started. What's going to have a major axis of 10 is going to be right what, left what? Right 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I already know that much. Major axis is 10. And I already know that's the longest axis, major. The minor axis is 4. Up 2, down 2. If they said graph it, I'd be done already. If the center is at the origin, which we've already kind of assumed, find the coordinates of the foci. Well, you already told me it's horizontal, so the foci have to lay on the x, right? So let's put a random spot. I don't know where to put it, but we got to put it somewhere. Okay? What do we know? I know that 5 is this. I also know this is 2. And I know if I knew this one, I'd have the focus coordinates ready. Pythagorean again. Alright, that looks like b to me, right? It's the medium. 2 squared plus b squared, or question mark squared, equals 5 squared. Alright, b squared equals 25 minus 4. Square root. That length is radical 21. Well, what's the question? What are the coordinates of the foci? If that length is radical 21, what's that coordinate? Negative radical 21, comma 0. There's one answer. And positive radical 21, comma 0. There's the foci. Pythagorean again. That horizontal word was huge. I don't want you to place them on the minor axis. By saying it's a horizontal ellipse, I knew the foci had to be on the horizontal. Okay? Any follow-ups? You're going to get to see it, I hope, again tonight. If you want to check, hey, is this going to be online tonight? Just come down 8th period. I'll let you know if YouTube for School's worked or not. I hope it does. I'm good, Scott. How'd it go?